Okay. So welcome to the colloquium of the Institute of Applied Mathematics. We are very pleased to have our former faculty members, Professor Rainer, who is joining us. Actually, he's in Turkey. He wanted to give the talk also in a physical environment, but we kindly asked him to take part in the online version of these seminars. He is currently teaching staff on mathematics and physics at Bavarian colleges. He obtained a mathematics physics diploma in Heidelberg University, and he holds a PhD in mathematics from Potsdam University in 1994, where he headed a research group in gravitation camp, geometry and mathematical cosmology until 2000. From 2000, he additionally specialized in actuarial mathematics and stochastic finance, and works as a risk consultant for financial institute and in energy trading companies. And he also teaches mathematical finance courses. We are very happy to have you, Martin, again. So I leave the floor to you. You have 45 minutes. After that, we are going to have the questions. Thank you.
Yeah, thank you for your nice introduction, Sefta. So what I want to talk about is actually, which maybe you know also from your classes, it is relative pricing. And I maybe because I think some students among you who know the conventional interest-based context of relative pricing, namely discounting or discount factors. And in this talk, I will start with this, and then I will show you that there are some reasons and to go away from conventional interest-based context to asset-based so-called numeraires, which in this context. So the title of the talk is Relative Pricing from Interest-Based Discounting to Economy-Adapted Numeraires. And of course, you see a picture which I actually took when I was in mountain climbing, and you see, of course, maybe you can realize there's some loose rock, and loose rock means, of course, risk. So for this purpose, I have this because it reminds the risk. So the agenda will be to start with interest rate models. I mean, the first part is just things which you should know. Interest rate models, then change of measure, the Kirsanov theorem, as it's called now. Of course, it is longer ago due to Cameron-Martin, the foundations in stochastics, but in the financial mathematics context is known by the name of Kirsanov. Then, of course, a conventional discount pricing derived from that, and the relative pricing and choice of numeraire, so repeated in the conventional context. And then I will make the step to go to show relative pricing with respect what I call essential assets. So by essential, we will see it comes to the economical context, and we will see what has to be taken into account in order to be relevant and adapted. So I will give two examples actually of assets. Rather than taking a whole basket, I just take one resource. So this will be something like potable water. And then I will explain how this little bit works, this relative pricing with asset-linked currency. I will also discuss to take this asset numeraire as a currency, as the advantages and the requirements to that. And then I will give a second example where I show the potential also for regulators, namely to regulate noxious output, like, for example, carbon emission related, regulating the maximum amount of carbon emissions. So let's start with a repetition. I think I will not waste too much time, but so here you should see familiar things. You know, interest rates can appear in different forms. You have instantaneous forward rates, for example. You have rates. Usually in interest rate modeling, you have what is called a term structure. It means you have different maturities, and the discount factors, in essence, they are derived from 0 bonds and as their expectations. And you can have also so 0 rates, which I mean, if you are related to this instantaneous rates, and by integral instantaneous rates and short rates are functions from reality, because in reality we have a continuous monitoring of, so the continuous models are always an abstraction of reality, but an abstraction which sometimes works efficient in modeling. So for this purpose, we are studying that. And forward rates to maturity in the future measured from today.
Martin,
Okay.
your sound is just getting weak and then disappearing. Is there any?
Okay, I can try to come more close to the microphone. Is it
yes,
better?
yeah,
Okay.
It's not very ideal for you, but that's much better.
Okay, I try. Okay, so this is an overview of a different rate. So there are the short rate models. Just to remind you, the short rate can be modeled, of course, by stochastic process. You have here standard Wiener process, and you scale it up in the variation, and you can also have a drift, and this drift is calibrated to the term structure. And yes, and if you have the short rate from the short rate process, then you derive your 0 bond prices today for given maturity t. You derive as the expectation of such an exponential. So we know what that is. And now for short rate models, also to remind you, there's this class of affine term structure models. So it means it is just an affine term, affine dependence on the 0 rate. And you can, as you see down here, if you have the drift as an affine process, and you have the variance as an affine process, then we say that the model has an affine term structure. And if this is the case, then the price has such the 0 bond price has such a structure that there's a prefactor and exponential of minus b. So there are famous names. There's this of term structure models, depending on what you put in for the different parameters. There's what is called the Vasi check, and then there's also the Hall-White model, which is the difference between the upper two and the lower two is that here you have a time dependence on the drift. And traditionally, so actually this Hall-White model class is still good. It admits also negative R values. For some time, actually financial engineers more than 10 years ago used to believe interest rates should never become negative, but this has been turned wrong by reality. So let's say 15 years ago, So there was actually there some people who preferred strictly positive interest rate models, but now in this time, now people know that rates can become negative, and so they stay to this class which admit this. So if you have, what is the advantage of such short rate models? Maybe say you get actually then from the stochastic differential equation, you get usual differential equation and analytic solution from such Riccati type of equation. The general disadvantage is of course that the short rate is actually an extrapolation which is not really directly observable from the time structure. This is a price you pay. When we have the short rate models, they calibrated to the zero bond prices. This works. We have an assumption behind it, which is the assumption of a complete market. And then if this is fulfilled, if this assumption is true, then the pricing measure is in fact the unique risk neutral measure. And it can be given by this, what is called the stochastic exponential. Some mathematics, we call it also Radon-Nikodym derivative. And related to this coefficient lambda, so this coefficient lambda here is the risk premium per volatility. It's also called market price of risk, and can be easily accessed. So also the price of the zero bonds then has such a process, and the Gesanow theorem says what happens if I change my measure. So from Q0 to Q. So here then we get a new process where effectively only the real drift is changed. So there's a change. The change of the measure always generates a change in the drift by the risk. And this is a principle I will show you on two examples, classical examples. One will be the forward rate models, and one will be the change in the currency, so what is called the quanto adjustment. So this is a classical examples, and so the principle is always we change the measure, and we will see that in essence what will happen, that we get a change actually in the drift here. Yeah. So and this means of course that the time structure is different with a new measure, and I have to, of course, to know which is really which is a risk. If I have the so-called risk neutral measure, then I can apply all the martingale techniques only in the case that I can transform this drift away. So this is a trick in essence, and this is the idea behind discount pricing. So I take the zero bonds as numeraires, and I introduce a forward martingale measure such that the relative prices here, they become such martingales. So relative prices with respect to numeraires. So the basic idea behind that essence, this is a relative pricing based on zero bond prices. This yields what is called the discount factors. Now, this works for, I can discount in principle any tradable asset, and in finance history, so 15 years, used also to apply it to LIBOR rates. And actually, even 10 years ago, I was with Ömer Hoca. He's not among us right now. We have been in a project in Frankfurt. LIBOR type forward rates. And the assumption of that is that these LIBOR forward rates, they are interbank rates, and that they're really tradable. So this, but it turned out there's a lot of in the interbank market, and from 2007, so it became obsolete. So it turned out they are not really efficiently tradable. So they are more manipulated than tradable. And in fact, finance industry has turned away from using these LIBOR rates. So this was an important lesson. But nevertheless, historically, I show you just quickly. So you have a log normal forward rate model. We don't have to see all the history, so from the old transparencies, and the stochastic processes, they are correlated, and so this is all we have to know. We have a log normal process for the forward rates. Of course, the correlation can be transformed away, which you have to do if you do a Monte Carlo simulation, which we have done the merger at that time. This is the main reason why I mentioned it. The other is, it turns out the Brownian motion, if I go from one forward rate period to the next forward rate period, so from there are several periods successive after has its own forward rate. And if you transform from one to the next, you have a this change of the measures process. So we see here it is a martingale, and if we come to if you see our Brownian motion, which enter then the forward rate process, we see that there's a change in again a Kirsanov type change of the drift by the factor k, which is given here. So this was one example. Yes, you see again here this marked up expressions for the drifts. So this was in 2010, is now more than 10 years ago, was a project where it was supposed to save the risk an efficient LIBOR market simulation we set up. Another example is if you have quanto. Quanto means we have different foreign currencies. We have foreign currency, we have a domestic currency, and we have two different types of exchange rates, and we have two type of log normal forward rate processes, and these two processes, they are correlated, and this correlation again leads to a drift adjustment of the which is in a sense also again effect of Kirsanov theorem. So conventional relative pricing. So just to split up, I have an asset which should be tradable, and I put bonds as numeraires. So now themselves are not sufficiently tradable. So, and also the LIBOR rates don't reflect true market. So they don't reflect economic reality. So then it is also that the zero rate derived from it, they are not the real rates, but at best there is an inflation on top. Maybe there's even something more. The conventional pricing method, which consists in considering discounted payoffs by just dividing by the zero bond. This leads to discount prices, which are supposed to be martingales, and the market is supposed to be arbitrage free. They are supposed to be equivalent martingale measure, and arbitrage free prices. So in order that this measure is unique, the requirement is that the market is complete. And so the question is also is it really is it a unique fair value which we obtain? And as we said, the implicit assumption by all this process is that this zero bond reflects the true reality and the true fair value. And of course, if the interest rates which are implied by these zero bonds, if they decouple from the real economy, so which happened in the LIBOR crisis and in particularly evidently, then it is maybe also not a good numeraire. And so this was motivation also to look for a new alternative benchmarks for economy rather than the zero bonds. Maybe we can put something else, something which is more to real economy. Actually, this idea also exists somehow in the context of what is called Islamic finance. However, in this context, also the so-called Islamic banking industry used to use a lot of workarounds, rather avoiding interest rates formally, but not essentially. So what is the main target of the criticism is that actually these zero rates, they don't reflect the true economic reality. And on the other hand, also they set the target of economic growth in the currency, which is related to the interest. So let me come to the relative prices. Now the idea is that we put something else, something else in the denominator, and this will be here the price of some real assets. So what should be this real asset? We will talk about this. Somebody is coming in. Okay, welcome. So real assets, so that should be something which is really related to my economy. And the new measure now supposed maybe better to reflect the economy. So I still make the martingale assumptions that the future is the quotient same as today. This, if I take assets here, they may, of course, still be stochastic at maturity, which is a difference to the zero bond. The zero bonds, by definition, are designed such that at the maturity, stochasticity disappears. So this is one, maybe one difference. And so that there is not necessary with this asset numeraire, there is not necessarily terminal maturity. So this is very different with the discounting approach. So, and now the question is, I have maybe this new, this may be composed from a basket. And the question is, will it be stable? So before I come to discuss it, I want to put some general warning, which maybe you know. If you take the expectation with the measure of a quotient of two stochastic assets, so in general, the expectation does not factorize. Of course, if they are 100% correlated, so if one is proportional to the other, for example, then of course you can do that, and then the forward price is just the conventional forward price, as you know. But in general, you should simulate everything actually together. You are not allowed. We are not allowed to separate it. This is also something which somehow in this conventional design, by the fact that at maturity the forward rates become deterministic, is sometimes concealed. So So then we have a deterministic, in the conventional approach, we have a deterministic discount curve, and we just multiply it it is just multiplied to the expectations to the evaluation of the asset. So here from the very beginning, it is obvious we have the numeraire asset, and we have the asset we are interested to price, the relative price, and we have to look at them together. So, so this is one first important point. And then it comes a point, of course, how do I select what are the essential assets which I put in here? It means the choice of the weights. Of course, if I make a bad choice of weights, this means, in essence, I will not be very well. So this will not be maybe reflect what is my economy, or what are the inputs of my economy. So what are the assets which should go in here, and by which weights they should go in here? It influences essentially what comes out as a value, as a relative price here, but it also influences the concept of risk. If I consider, for example, the variance of these relative prices. So in the recent paper, which is mentioned actually in the abstract of this talk, also there are some arguments also that if, for example, this underlying, so this numeraire asset, if this is anti-correlated, so if they go in opposite directions, then it leads to the maximal volatility enhancement, so which is actually also one of the disadvantage of the conventional zero bond prices putting in. But okay, away from the side remarks, so what should I put in here? First, of course, I should put in the important resources which my economic unit needs. So if, for example, if I'm producing bread, I need water, I need wheat, and such things. So this should be my input resources. Maybe I should put in. But if I'm in industrial production and I produce carbon type emissions, so I should minimize them. And because I must minimize them and I'm punished it, so I should also include them actually under my cost somehow. I should price what I have here in such a manner that the value will be reduced. Actually, the more output I have, and the more input I need, and the more poisonous or undesired output I have, the lower will be the value in here, the relative value. So maybe this is also the point to look at the publication. Actually, I was a little bit also surprised. Now the first ideas are also more than 10 years old. And a lot of things were done also with Serhan, who was also at the institute for quite some time, and now is in Estoniya University. And we had started also to work together, also in the context of Islamic valuation, financial engineering. And so then it lasted quite some time until this was published, so more than 4 years, and I was not so patient. So I also submitted another paper to a journal where I explained to some of the instruments of Islamic finance how the asset valuation techniques can be applied. And now the recent paper, which appeared online in autumn, something like 19, now appear finally in the journal in 2022. Yes. So this is a journal where also some details more explained. For example, how, as I said here, if I look, this I look at variation of this relative prices. Yeah, so I can do some approximations and yes. Then also some two examples are given. So one example is that I look just at one resource, something like a valuable resource. So instead of looking at the whole basket, now I just look at, say, potable water per square meter at some location. Also, I put in this here in order to make you aware. Of course, we have in different regions of the world, we have different economic situations. And we have, of course, different situations, different prices for the same commodity in different regions. In fact, also this applies to conventional currency. I should mention, for example, if we have Europe and we put all under the euro, and it doesn't reflect, of course, the local economy of Greece, for example, and this also created some of the crisis. Yes, because local economy of Greece maybe has a different input-output structure than the average European economy at that time, at least. And okay, but if you now just water, it is also maybe one of the most basic resource for human existence at all. So, and also in this context, maybe I should mention that this asset numeraire is something what was proposed by the so-called Islamic finance industry is the gold standard. Go back to the gold standard. We had also the gold standard for the dollar and for historically in the last century and so on. But of course, gold may be not the most precious or the most valuable commodity in our modern times. So we have to think what is the most essential and most basic commodity. And I used to say, look for the gold of the 21st century. And in this context, we come to such resources like potable water. Of course, also I mention what is the properties which are required in order to have a currency, or to that a resource may be suitable as a currency. It should be fungible. It means available. It should not decay easily. It should be transportable, recognizable, and stable. So at least to some extent, for these essential commodities, this is more or less true. And of course, with variation at different locations. So the idea is always also locally adapt. I consider a certain economical unit, and I consider the activity and the input-output of this economical unit. This can be a company, this can be a nation, or or it can be something like European Union. On each level, it depends which unit I consider. So I will need a different type of numeraires. But also now, if I now have this example that I have potable water, of course, if I'm in the mountain region where it's available, maybe the price in euro is a different one than if I'm in the area. But the point is, if I put a currency, if I say, for example, 1 cubic meter of potable water, and I put this as a currency, then immediately, if I, for example, price everything in terms of this currency, yes, so 1 unit is the same, of course, in the southern zone only that, of course, it's evaluated in another currency, then the price may be different. Of course, now, yes, then you may say, yes, in any location, you can just transform the price. This is true, yes. But the point is, if I have now, for example, assets S, which are depend on the input of potable water in the production, the production of bread or agricultural production. So these relative prices, they will be the same, more or less, if the independent of whether the price of potable water is in this region low, or if the price in euros of this resource is high, as long as these prices are proportional to each other, more or less. Yes. So we see already some effect. So the local relative price measured in local currencies. This is what I look at this. So what happens if this asset which I'm interested in does not depend on the potable water price. So it is decorrelated. The correlation is absolutely small. So let's assume then this potable water goes up, but since this price is not affected very much, so it means that the relative price will go down. So they will depreciate. The relative price will depreciate. If the correlation, on the other hand, of those are strong, so if they go in the same direction or they are almost proportional, so this means if the resource potable water is going up, so then also the price of my bread or what I produce with this potable water is going up. But they both go up, but the relative price remains quite stable. So it's an effect, actually a stabilizing effect of taking such an important resource as an input or as a numeraire for the pricing. So this is the essential idea. So of course I can also now go and do some stochastic modeling. So this slide is maybe still stochastic model, some Levy process, some scaling up, and some trending, drifting, and so on. So I could do this for any commodity which I put in for potable water, and if I have more, I have several of them, and of course there come some challenges later about implementing such baskets. But in principle, yes, this is possible. And if I want to do risk modeling, maybe I should also set up such a model. Of course, yes, and then it is whatever it is. But if I want to do some extrapolation to the future, so maybe I want to fit a suitable model, stochastic model to it. Now, what is the advantage of taking such an asset, commodity, maybe as a currency directly? Rather, I could also say I set up again a type of zero bond, but the zero bond is asset linked. Such instruments exist. They exist. For example, consumer price linked zero bonds, and I think some of your students, Aydın has some years ago made a thesis on such a topic. And yes, so what are the differences? So first of all, the zero bonds, of course, they are not fungible to everybody, so they are not available to everybody. And also, I can hedge my risk only if I buy the zero bond in advance. If the risk already has happened, or the movement in price already has happened, the price of the zero bond also will be high. So this is one difference, because assume I have such an asset-linked currency, so it will be available every time. So, and if I have issued my contract in such a currency, I will be safe against the inflation risk. And also the risk will always immediately be transparent by the fact that conventional currency like lira or euros, they will of course depreciate in such a situation. This is a difference that this currency is fungible, and it gives permanent protection rather than hedging only in advance. The effect actually will be also, I think, considerable if we think about our labor contracts. I tell you some example about Germany now in this inflation situation. Of course, maybe for Turkey you laugh about it, but in Europe and Germany it was we had interest rate which was 2%, something like that. So and now and also wages used to increase. Now in this year, agreement was made for government employees in Germany. So by next year, by 2023, we get increased by 2% something, but we have an inflation rate far above 7%. So this means the value of our labor degrades by more than 5%. You see in conventional currency, the degrading and the step-by-step impoverishing of society somehow is hidden. Why? For example, if I assume I would have issued labor contract in such a asset-linked currency, so which includes maybe a consumer price basket, which is realistic, really. So I would be essentially protected against the increasing prices whenever they happen in such situation. Okay, so then let's come to the question. So what is necessary to realize such currency? So probably in our times, we should use the experience we have for digital currencies and digital currency techniques and use them. And economically, of course, we can evaluate the input assets. First, we can evaluate them in auxiliary currency, which is our local lira or euro or US dollar, whatever, wherever we are on the earth. And then we have to, of course, to specify the input-output structure. Which means to specify the weights, these weights here, yeah, these weights must be specified. So, and yeah, I should specify these weights. Now, in this slide, I set up a little bit a hierarchy. So, what I should include, what type of assets I should include. And I go bottom up from subsistence. So, what is the most essential human needs for existence? So, drinking water is the first. So then, of course, food, vegetable, wheat, and whatsoever. But some small amount also of non-vegetable, which we need, we need vitamin B12 and others. And we need heating, housing, light, basic health care. Let's say something like this, which is, let's say, human subsistence. So I can consider next level. I can say, okay, I want more. And then, of course, this should be included in the numeraire. And I also have more requirements for a real social existence. I need mobility. I need infrastructure of society, electrical, digital communication, excuse me. And of course, the more I require, and the more industry I need, the more complex technology I need, and the higher is also the social, economical, and ecological costs. And it means the more I include, so the higher are the costs. And of course, it's also one of the tasks to work out the sustainable limits, what I should put in here. And this leads to the second example, which where I put now as an example, I put an undesired output, namely this carbon type, carbon equivalence emissions. CO2, it may be methane and so on, which we know. They are all measured in carbon type equivalent. And so I have the price of such emission now dependent on the quantity which is emitted. So I have a quantity dependent price. So if such a scheme allows me or allows some regulator, so if he puts, and it's actually something which is also done in something like, or at least in the philosophy of the European scheme, regulate some maximum amount of sustainable or still sustainable emission in order not to increase to beyond the critical value about temperature increase and so on. And if you now have an efficient market trading of such allowances, which are so dependent, the price is dependent on the quantity. This means the price will go up, of course, if I go with my quantity to the sustainable limit. So naturally, because this limit, if this is strictly regulated and companies cannot exceed this limit, it means that theoretically, so this price should go up to infinity, which will prevent companies by force to reach with their produce such a limit. So, and this can be done, of course, by setting up somehow a nonlinear, such a nonlinear dependence in the price. So if I'm a regulator and I can set up, regulate the quantity dependence of the price, I can put in a quantity dependent factor, which regulates somehow in such a manner that it prevents efficiently by free trading the excess of the quantity. Okay, so this is the idea of that. And also here you can look, of course, so we have left the price of an asset measured in local currency of allowance for a quantity of its own implied emission of carbons over some period of time. And now we can look, now if the emissions go up, so then the price, of course, the quantity goes up and the price goes up and the asset depreciates. And of course, the closer I come to the limit, the stronger is the effect. Also, maybe I should mention here that I forgot to mention, of course, I can do it in such a manner. In conventional economy, I have a linearity, so with quantity. So it means I put in double 3 times the quantity, I have double 3 times the price. Yes, I can do it in such a manner that I have approximately linear regime. For example, with this function, I have a approximately linear regime for low quantities. But only if the quantity reaches the limit, it becomes not linear. So, okay. Let me come back to the specification of the reference currency in order to sum up. So what is required to specify it? First of all, I should timely, regularly monitor asset prices in the auxiliary currency. And second, I should also very well specify needs of the basket. And this is also critical because, of course, if I don't specify them properly, they don't reflect my economic activity, and I'm not well hedged. So against movements. So the hedge will be degrade. So what I should assess is what might be called misspecification risk of weights, and this is also something one should study, of course, in the studies. What happens if these weights are misspecified? They vary by, let's say, 1% or something. So what happens? And I also should assess the risk of my deviation locally, because let's say if I have a commodity which varies actually locally, and I'm inside a larger economical unit, and I have a currency available unit, but my personal economical structure deviates. So how much is my risk under this deviation if I use this currency? So that could be also the question, for example. So how much is the risk of Greece if they still use the euro, or if they still use also a currency which is adapted to global European economical activity, but local economical activity deviates. So anyway, so they will of course have worse protection. So now let me come to the conclusion. So what I propose, or we propose in such papers, is a change of paradigm from monetary growth to sustainability and conservation of value. And this is related to new pricing measures away from the numeraires, from the zero-bond numeraires to relevant assets. That social advantages of the central protection, inflation in particular, also for and also protect against poverty, and that, for example, in particular, that the most essential resources we have, like, for example, we see now, by load. So there should be some protection also against poverty, so that the price of bread somehow should be always in a proportionate relation to the contracted value of labor, for example. And this was the first example. And the second example was also, I tried to show that regulators for, let's say, carbon emissions or carbon type emissions and other noxious, maybe exploitation of global resources, they have a tool also to regulate it by putting limits on the quantity which affect the price. Then, of course, since we are in mathematics, also we want to have some challenges, and I say what I say, that computational and simulational challenges and modeling challenges are not less. So interesting problems emerge. So I must simulate the relative prices of such basket currencies and for different economical scenarios. So it would be valuable to have such work which can demonstrate how this really works. In some, we try, for example, to work it out for Turkey or for some sector of Turkey. And it may be, by the way, also it may not only be for consumers, it may also be for producer branches. So for any type of economical unit, you may work out such baskets currencies. And of course, then the task is to assess the misspecification risk under variation of weights. So how much is the effect of not appropriately specified the economical structure, and then, of course, if we go deeper in the mathematical modeling, we know that commodities, they have, for example, larger tails, and they may have also some features which require non-log normal processes. And I can look for all the generalizations of Gerzanov theorem, which partially also exist. And I can look also for Levy processes with terms. And also, since I have baskets, I can look for analytical approximations. So we can learn something, for example, which has been done for Asian options. And this type of analytical approximation by Taylor-Ito approximations. And of course, also, I didn't mention to put on the list here. Also, one should work on the digital technologies which are required maybe to set up or make available to make fungible such currencies. So this is particularly interesting at your institute because you are close also to people to working on cryptology and everything which is related to make a safe currency and so on. So I try to show you that, of course, it matters also to which problems we apply our mathematics in future, but we have the opportunity to apply to problems which maybe help to improve something. And I want to end here and go to the discussion, and hope I can inspire you for new projects in this direction and maybe some collaboration. Thank you very much.
Thank you, Dr. Rayner. Teşekkürler, Martin. Thank you. So it was very nice. Also having a capture of the financial mathematics applied to very nice economic problems as well. I just first leave the floor to the participants if they have any questions. So I would like to remind that if you would like to ask with using your voice, the participants, we allowed you to just ask in person. If not, you are welcome to type it in the chat part that I will just read it for you.
Sevtap Hocam, I have a question.
Oh, thank you. Yes, Murat.
My question is in example 1, potable water. We have an stochastic process with drift and Levy process. Yes, and I didn't quite understand this here. The drift and deterministic trend and this Levy process stands in real life.
Ah, okay. Yeah, this is not yet an elaborated example, but as we know, for as many of these inputs as I proposed, if you look from a list, are commodities. So we know that for commodities we have a different distribution structure which deviates from the normal distribution by more heavy tails. So this may be one indication, so that you need something more general than the normal type of distribution, going to some more general type of Levy process rather than Wiener process.
And also in this stochastic process, we are given a log of CXT. Can we change it, for example, for exponential or another type?
Yeah, yes, of course. This is you can do it. So this is exponential of normal model. Yes, you can do it. There's a transform. There's a transform of measure, and you need then the transform of measure techniques, like a stochastic exponential. You need them.
Well, I understand now. Thank you.
Any other questions? Any hands raised? I don't see. I mean, I'm just curious, when you started your examples, you mentioned about the geographical reactions to the prices or its influence. Can we talk about a kind of stochastic spatial correlation among those, or is it not imaginable?
I mean, we have, of course, in different regions, we have different different developments. I mean, usually, if you go from one region, it depends what we consider as a type of commodity. I mean, if this region are separated by hard borders, so they could, to some extent, they could develop partially independent, so it could make sense to model them, yes, and just in such a manner that they make different processes which are correlated in different regions, and then I try to tie them up to a process for the whole region of all the sub-regions. Yes, for each sub-regions I could set up, I could have several sub-regions, and I could have a process set up for each sub-region, and then the sub-regions, they may have correlated processes, and I could imagine somehow to have then a resulting process for the whole region. Yeah, something like that.
Which would make it more strenuous, but okay, thank you. So any other questions to our speaker? So we are really good in time, German time.
Thank you very much.
Yeah.